point out that automated closed captioning is available. You can access this by clicking on the three dots at the bottom corner of your screen. If you experience any issues accessing the closed captioning, please message the BIN organizer on the webinar, and we will go ahead and get that sorted for you. And I would also like to acknowledge that I'm joining you today from the Lenape lands. We're all joining this event from places around the world. And so I invite you to take a moment to reflect on the lands you're joining from, as well as the relationship of those lands to the Indigenous people who have and continue to inhabitate them. So I'm Ashley Cunningham, and I am a co-founder of Black in Neuro, and I run the merch store, and I also am involved in the seminar series. And I'd like to welcome you to our seminar series today. So in this series, we plan to feature neuroscience faculty, neurologists, postdocs, and graduate students, and we hope to provide a stage for them to share their science, their paths, their setbacks, and their triumphs. And so we hope to celebrate our community and hope to change the broader community's idea of what a neuroscientist looks like. So just some additional logistics. After the talk ends, we'll have 10 to 15 minutes for questions from the audience. So throughout the talk, you can feel free to use the Q&A function, and you can also use the Q&A function at the end of the talk. So feel free to access that. And if you feel inclined, you can share any tidbits that you learned today on social media using the hashtag BIN Seminar Series. And so today it's my honor to present our speaker, Dr. Tony Larkin, who's a postdoc at the University of Michigan and a co-founder of HBCU DAP. His research interests span examining mechanisms of sensory hypersensitivity among chronic pain patients and healthy individuals. To date, his research includes the use of functional, connective, and graphical theory analyses on data acquired through non-invasive neuroimaging, such as fMRI. And he uses this to try to understand how the brain works as a complex system. And so without further ado, please, Dr. Larkin, welcome.
Thank you so much for that introduction. It's also still kind of a lot interesting to hear Dr. Larkin. But I want to thank everyone for deciding or choosing to enjoy their lunch or breakfast and attend this talk. Also, that I know that a few people may actually still be in the queue to get Beyonce tickets. So yeah, I really appreciate you kind of tuning in to hear me. Before I begin, I would like to first also take a moment to acknowledge the families, friends, and communities impacted by social justice currently faced across the United States and the world. Thank you. So for the past few years, I've examined the organization of the brain as a complex system to investigate network mechanisms of hypersensitivity and chronic pain. I preface my talk with this picture as it highlights that the brain is broadly organized in a way that each of the 5 senses or sensory modalities have a designated region of the brain. Visual information in green is processed in the occipital cortex or the back of the brain. Touch in red is processed in the primary somatosensory cortex at the top of the brain. However, aspects of the subjective experience or sensations like pain, often associated with sensory processing, remain poorly understood. About a third of Americans suffer from chronic pain. This presents as a huge financial burden on patients and their families. Chronic centralized pain disorders are characterized by abnormal responses to stimuli, both elevated responses to painful and non-painful stimuli. Today, I will focus on analysis I have completed in fibromyalgia, a prototypical nociplastic pain condition, where patients experience widespread pain, as well as fatigue and cognitive dysfunction. Additionally, many patients have heightened sensory sensitivity to multiple sensory modalities. Neuroimaging studies have allowed us to identify and confirm many of the brain regions involved in pain processing. Additional studies have further confirmed their role or their relationship within the context of chronic pain. Sensory information from the periphery typically enters into the cortex via the ascending nociceptive pathway by the way of the brainstem and thalamus, which send nociceptive signals to the primary somatosensory cortex and insula. In turn, the descending pathway on the right is typically associated with aspects of modulation of this nociceptive information and is considered to be anti-nociceptive in some cases or even analgesic. Most importantly, none of these brain regions identified here are uniquely associated with the pain perception. So I measure the relationship between brain regions, referred to as functional connectivity, as the covariance in both signal between brain regions over time, extracted from fMRI time series. Many brain regions, like the PCC and MPFC shown here in yellow and orange, are intrinsically connected, and through independent component analysis, one can identify spatial and temporally coherent networks of brain regions that are also functionally relevant. The spontaneous activity within or between these networks may provide a richer source of disease-related changes that are involved in the underlying pathology of pain. One of the most well-known or studied networks is the default mode network, which consists of brain regions that are typically less active during tasks or more active during rest and involved in self-referential thought. Previously, work from my mentor, Rick Harris and Vitaly Napadal showed that patients with FM have increased intrinsic DMN functional connectivity. Specifically, increased connectivity between the DMN and the anterior insula, a brain region involved in multisensory integration and salience of sensory stimuli. This connectivity is correlated with clinical pain, such that patients with higher connectivity or have higher pain. Many labs and research groups have gone on to actually replicate these findings and understand the nature of this connectivity in multiple contexts within pain. As this finding reports that altered intrinsic connectivity within FM, I was particularly interested in assessing the functional connections across the brain simultaneously to further examine network mechanisms of chronic nociplastic pain. So to do this, I use graph theory. Graph theory is an interdisciplinary technique used to study complex systems. In this framework, a node represents the components of a network, and the edge explains the relationship between two nodes. Communities are modules or groupings within a network generated by community detection, and modularity of the network quantifies the density of connections within a community relative to between them. To study the brain, and for the purpose of this talk, each brain region within these networks represents a node, and the relationship between them is calculated by the functional connectivity. The solutions of community detection algorithms or their use may identify a priori clusters of nodes or reveal new organization of the nodes within the network associated with unknown aspects of the system. In any case, the underlying community structure of a network may reveal novel interactions of the components within the network to understand how it functions. Familiar applications of graph theory include friendship networks that can be generated from social media, identifying friends or groups that include friends of friends. And a personal favorite of mine include transportation networks like airport networks. You may choose to purchase flights from a hub airport like Chicago or Detroit, or that as they may have more flight options around the world compared to the fabulous regional airport. Interestingly, hubs are sensitive to the function and flow of the network, and as we recently observed with the major malfunction due to during the busy holiday season, sub-zero temperatures or a glitching code could make getting flights out of a hub airport like Chicago take days. So our first step, one of my first steps in looking at graph theory was a part of the study where we looked at the hub structure within FM patients. We found that there was a shift in the hubs among FM patients with high clinical pain, where hubs were typically in the posterior visual regions of the brain in low pain patients. Sensory motor and salient brain regions, to include the insula, are hubs among high pain patients. Yet it remains unknown how the functional brain intrinsically organizes into communities and whether differences in organization persist in chronic pain. With the overarching goal to identify neural mechanisms that contribute to sensory hypersensitivity, the nature of my research focuses on two main questions. Are there intrinsic alterations in CNS or central nervous system, in the central nervous system associated with chronic pain? And how does the supraspinal or visual specifically processing result in the altered perception of pain? We predict differences in these network structures may further reflect aspects of clinical pain and may be associated with sensory sensitivity. Using graph theory analysis on fMRI data, the aim of the study I will discuss today was to determine whether there are differences in the intrinsic network structure of the brain in FM between FM and individuals with FM and healthy controls. I'll describe data from two data sets of FM patients and controls used as the discovery and replication data set. Both cohorts consisted of female FM patients with age and sex matched healthy controls that underwent a resting state fMRI scan. Prior to the scan, participants were asked to rate their clinical pain on the visual analog scale. Networks were constructed using a previously published atlas, and the fMRI time series were extracted and correlated with each other to create our functional correlation matrix. We used a community detection algorithm that incorporates fully connected and weighted edges over 1,000 iterations, followed by consensus analysis to identify a subject level partition at thresholds that range from 0 to 1. And so again, the question that I was seeking to ask was, are there differences in network architecture between chronic pain patients and healthy controls? To assess the community structure between two networks, we used normalized mutual information, or NMI, which measures the similarity of community structure between two networks. Higher NMI suggests similar community structure between two networks, and lower NMI suggests variable or different network structure. For each individual, we assess the similarity of community structure within the group, comparing FM networks to all other FM networks and healthy controls to all healthy control networks. We also assess similarity between groups, comparing each FM network to all the healthy control networks. As we applied these analyses on our discovery data set, we found that FM patients have significantly lower within group NMI and between group NMI compared to healthy controls. This would suggest the community structure of FM networks are more variable and different. We found no difference in the community number or the number of communities within each network or the modularity of the networks between groups. We wanted to determine if these results hold using our replication data set. And indeed, we found that in our replication data set of FM patients and healthy controls, we again observed that NMI was significantly lower among FM patients. Once again, there were no differences in the number of communities and modularities within this data set. Together, these results suggest that the community structure is more variable and different among FM patients compared to healthy controls. As with all research questions remained, is there a relationship between NMI and the intrinsic connectivity? More so, what is really contributing to the differences in community structure in FM? So I previously mentioned that the community structure of brain networks may reflect aspects of the brain functional connectivity, and thus NMI may be associated with the intrinsic resting state network connectivity as a priori communities themselves. To test this, resting state networks were generated using independent component analyses, and regression analyses using NMI as a covariate were conducted to determine whether there was a relationship between NMI and resting state functional connectivity. We found that the DMN, or default mode network connectivity, was negatively associated with NMI, suggesting stronger DMN connectivity was associated with networks that have lower NMI and are more variable. We saw this relationship between the DMN and insula, suggesting individuals with stronger DMN to insula functional connectivity also had lower within group NMI. Of note, this connectivity was reciprocal in that when we did this same analysis using the salience network, the DMN brain regions were also negatively correlated with the NMI. The question remained, what or how are these communities different? Using phi coefficient to test the consistency of node community assignment across subjects, we discovered that many of the nodes in their community assignment between FM patients and healthy controls varied. In the figure to the left, I'm showing the nodes on the y-axis and the subjects on the x-axis. The color in the heat map designates the similarity in node community assignment as measured by the phi coefficient. Higher phi with warmer colors suggests that the community assignment was similar among patients, and lower phi suggests different or variable community assignment. In both replication and discovery data sets, all nodes that were different in the community assignment were more variable in patients. As these findings may suggest that the brain of FM patients are more noisy, we disagree. We found that FM patients with high pain have significantly lower NMI compared to low pain patients. As we observed this difference in community structure across patients, we were curious as to what brain regions may be contributing to the group difference associated with pain. When we looked at the community assignment of nodes between patients with low and high pain, we found a collection of nodes that had significantly higher phi values among high pain patients compared to low pain patients, which included the insula. This suggests more stable community assignment for these nodes among high pain patients. Furthermore, these findings suggest that there is structure to the reorganization of the brain in chronic pain patients. Lastly, as this is a clinical pain population, we wanted to determine whether these network measures can be used as potential markers for nosoplastic pain. We measured if NMI can accurately discriminate FM patients and healthy controls. Using ROC analyses, we showed that the NMI successfully identified FM patients and healthy controls with both high sensitivity and specificity and accuracy of about 85%. To summarize, NMI was lower in patients with chronic pain compared to healthy controls. These findings suggest that there is structure to the organization of the brain in chronic pain patients. ROC analyses revealed that within group NMI discriminates patients and controls. And future studies are needed to replicate these findings and determine whether network measures can help in identifying and treating patients with similar features of chronic pain. So the second part of the next kind of question, or the follow-up question to these analyses, was we wanted to know whether or not this persists, this difference in community structure persists during presentation of a stimulus. And so across chronic pain conditions, hypersensitivity ranges from the immediate area of injury, which is typical of nociceptive pain, to diffuse hyperalgesia and allodynia, or widespread sensitivity to pain. But also in nosoplastic pain conditions, this sensitivity may be experienced with non-painful stimuli as well. Moreover, women with FM report heightened sensory sensitivity to non-noxious stimuli encountered in daily life, including light or visual stimuli. In our lab, quantitative sensory testing, or QST, is a collection of experiments involved that deliver sensory stimuli in a systematic manner to the body to assess the sensations that arise from it. Previously, from our lab, a study showed that an aversive visual stimulus presented to patients with FM and healthy control. Patients found this stimulus, it was a flashing checkerboard, extremely more unpleasant than healthy controls. And they found this over very different intensities, as well as the overall unpleasantness was significantly higher. Inside the scanner, the activity in the insula was higher in FM patients compared to healthy controls, and the activity during this visual stimulus, and that activity was correlated with the clinical pain of patients, showing that higher activity, patients with higher pain showed higher activity in response to this visual stimulus. And so it left the question, are there changes during this visual task in patients with FM, changes in community structure? So to recap, within group NMI basically is measuring the within FM to FM connectivity and healthy community structure, and measure similarity in community structure across networks within the same group. And between group NMI measures similarity of community structure between FM and healthy control networks at rest and during the check. We found that within group NMI was significantly lower in FM patients than healthy controls during both rest and check conditions, check being during the visual task. Although between group NMI was also significantly lower during the visual portion compared to the rest condition. And so to find out more of how or what happened with this, the paper is currently under review, and so I won't go into those details anymore. But I want to highlight the research team that helped me get these findings and the funding sources as well. Before I finish, I also wanted to take the time to talk about some of the other work that I've done, but more so just my experience and journey along getting to this path. So I'm showing the statistics of Black PhD recipients and showing that they make up a very small portion of the pie of PhD recipients, especially within the life sciences. Additionally, only 25% at the time of the survey, only 25% received their undergraduate degree at HBCUs, which and then went on to receive their PhD at a publicly white institution. And so I often, while getting this PhD, I was involved in a lot of different diversity efforts. And I often thought about, there were two things that I think that are extremely important for institutions and programs when thinking about DEI and integrating diverse populations within their program. The first one is understanding one's experience, and then two, facilitating an inclusive environment. And so I was involved in research kind of under these two themes. And I'm unfortunately very sad that I'm not going to be able to talk about any of it, but hopefully there will be a moment in time that I'll be able to talk about it more. However, we're definitely working to write up some of these analyses, and I'm really looking forward to that. But I also wanted to take the moment to share parts of my journey as I benefited from hearing other faculty members present their journey and their research within this platform. And so, as previously mentioned, I received my BS in biology at Morehouse College, and I was able and fortunate enough to receive support to actually be engaged in research as an undergraduate. And I think that that played a huge factor into how I have come and really motivates me to do this type of work and stay in the field. I also completed my PhD at the University of Michigan, but the journey to do that is very long and tough. And I say this more so for the trainees or undergraduates that are very interested in pursuing a graduate degree. And so I wanted to acknowledge a few of the individuals that were important in this journey. One of them is the person on the right in this top picture. I don't know if you can see my screen or my mouse. That actually, as I started my first year at Morehouse, told me about the RISE program and it really encouraged me to pursue a research opportunity as a freshman. And at the bottom, my mentor, my research mentor, Dan Hummer, who actually afforded me the opportunity to work in his lab. And as I started as a freshman, I'm showing this is not the exact vibratome, but I'm sure there are a lot of undergraduates that work in research labs that may be actually sectioning brains. But I just remember kind of going into the lab and you don't slice brains, you section them. And so I was able to section brains that were a result of stereotactic surgeries that Dr. Hummer and other researchers were doing at the time. And eventually I ended up doing those surgeries myself and went on to actually write it up and complete a honors thesis at Morehouse College. And I will say that, and so I highlight that to really kind of also emphasize that my experience was really kind of motivated or was something that helped motivate me. And so that I really find it important to kind of nurture undergraduate research experiences, no matter what institution you're at. And I encourage undergraduates to pursue these opportunities. The other thing that I kind of want to highlight for those prospective graduate students or seniors that are getting ready to graduate is that the journey to getting a PhD is not linear, and it's not almost. I initially expected kind of like to go right into medical school, graduate school immediately after undergrad, and that just isn't the case. But I really think the path that I took has been very fruitful in the sense that before graduating, I did take the GRE. However, after graduating, I took a year and a half or so as a lab manager at Georgia State and really got immersed in the research there, but also understanding the culture of graduate school. Seeing many of my mentors and peers go on to defend their thesis, it really encouraged me to go ahead and apply. And so I ended up applying. I also took the MCAT because I was kind of thinking about maybe still going to medical school. However, I will say that at this point, nothing down in that, but I'm very happy that I took this path. But I was able to start my PhD at the University of Michigan and complete it in the fall. And so as a part of my experience in diversity efforts, I was able to start a nonprofit with Sierra Nance, who is kind of very busily finishing up her PhD now at the University of Michigan. And I just wanted to highlight and show kind of some tips that we provide to ensure that prospective students that are currently interviewing a successful interview. So here are just a few tips. Make sure you send thank you interviews to your interviewer, thank you emails to your interviewers. Dress appropriately, professional and business casual, and casual when appropriate. Practice your elevator speech before you go to your interview. Remember that you are also interviewing the program. And so the environment, this is where you'll be getting your training. And so you want to know that you're in an environment that you'd like, because this isn't just 1 or 2 years, it's a long haul. Always be professional and always be yourself. And so I hope that if anyone knows anyone, or if you specifically are just looking for resources to help as you prepare for graduate school, or there's different components that you seek out, hbcudap.com. Or we also have an Instagram to really kind of just help look for templates, tools, resources that may be helpful for you. And hopefully soon we will be kind of back online with doing other programming as well. And so with that, I encourage questions and want to wish you all happy Black History Month.
Amazing. Thank you, Dr. Larkin. That was a really awesome talk. I actually had a question. Um, Given that you're like looking at these responses to pain, how do you um, account for the like opioid epidemic and how that may like influence how these different brain regions may be like responding to pain?
Yeah, that's a great question. A lot of these studies, so of course, a lot of individuals are prescribed opioids to kind of deal with their pain. But what's really interesting is that for fibromyalgia, I think it is kind of understood now that opioids may not necessarily be helpful in treating fibromyalgia. And so there actually may be other mechanisms or treatments that will be more useful. And so to account for, well, first to account kind of for the opioid use, that's something that is determined in the inclusion and exclusion of whether someone can participate in the study. But I think that in understanding kind of like the, I won't say the cause of the opioid crisis in a sense, but yeah, that's something that's very much so considered, especially that just opioids just I don't think work necessarily is kind of what I come to understand. But I have to say that I'm not necessarily a clinician, so I can't really speak on the how it affects treatment or not.
Awesome, thank you. We have a question from the audience from Angel, and the question is, how did you decide to go into this area of research?
That's a great question. Um, I think in graduate school I rotated and I found a lab that I definitely enjoyed the mentorship and the support, but also the environment. I think that as I kind of talked about my experience at Morehouse, really the environment kind of was it was nurturing, but it was something that made me want to go into lab to do research. And so when I was rotating, I also was looking at that. The other thing was I'd never done human research or research on humans, and I had always done research on like rodent models. And so this was something that I was kind of taking on that was different, and it was just really exciting at the time.
Awesome. Um, I feel like that transition from like between like species is always so challenging. So in your postdoc, do you plan to try to like incorporate now your um, mouse experience with your human experience?
Yeah, I think it's yes, to say that. I think it's hard though because I will say I plan to incorporate that, but I think that it's almost kind of ingrained in just understanding what's going on with the brain. In the sense, I think rodent models are very useful in understand. You can do a lot of things with rodent models that you definitely can't do in humans. But interpreting data that we get in fMRI, and even kind of identifying like those pain circuits, a lot of those brain regions, like in order to really probe and test whether or not they have a role or a function in pain, relies a lot on rodent models because we can't do like optogenetics in humans. And so I do plan to kind of incorporate aspects of that training in really understanding the results that we have. But yeah, I think that it was just very useful to have that experience as well prior to coming into kind of the human side of things.
So we have a couple more questions about your journey. So one participant is asking, what experience pivoted you away from pursuing medical school?
Yeah, that's a really tough question. And long story short, I had a summer experience that was really great doing research, and I was afforded the opportunity to kind of kind of see just different aspects of the medical field. And it wasn't that it was discouraging at all to pursue medicine. It was more so I really enjoyed being in the lab. And then I spent a day kind of watching surgeries, and I thought it was like so cool to see kind of a surgeon remove a tumor from the brain. But then I think after that, I kind of was like, I don't know if I'd want to continue to do that all day. Versus, I think in the research setting, I really enjoy kind of like running the analyses, interpreting data. And that's not to say that medical doctors and physicians don't do that, but I think for me, the training that I was kind of seeking at that time was more of research focused.
I definitely relate to that. I also was like medical school all the way and just fell in love with research. So I feel like we are not the only ones that have had that experience.
Yep, yep. And it's not bad. I'm not like upset of it about it at all. Um, there was a time where I kept thinking like, well, maybe I'll go back, and I was like, actually, no, no. I think I've definitely by the time I finished my PhD, I was kind of like, oh, I'm a little schooled out. But yeah.
So we have another question about your journey. So the question is, Dr. Larkin, what an amazing journey. And what are some other avenues you hope to pursue in the future?
Well, that's a great question. Um, I have no idea. I think that I'm planning to kind of continue academic research and stay on that path. And I think that really kind of understanding the use and the application of graph theory to neuroimaging data, I think it's something that really interests me. Um, and so I look forward to kind of doing that a little bit more. I also yeah, that's probably a good answer for now. There are so many other things I think that I find very interesting and intriguing, even outside of science. And so kind of doing that as well, and exploring those passions. I look forward to it.
Yeah, that's great. And I think the data that you showed on your interests in looking at Black PhD students, I'm like excited for that to come out and hear more about that. So we have a couple of more questions. How do you balance lab life and normal life?
Oh, wow, that's a great question. My parents were actually worried about that last night. Um, it's really tough, and I will say that one of the things that it's something I actually had to learn as part of being a graduate student as well. Um, it's hard, and I don't know if there's a particular recipe. But I think for me, it's more so kind of generating and finding that routine that works for you, and moving towards happiness. And so I think for me, it's kind of like understanding that there will be times where you have kind of like that experiment that's gonna go on all day, or you're kind of like working to get that grant in, um and it just you have a long periods. And so I think whenever I get into that moment, I also start seeking out other opportunities that aren't necessarily science or lab based, like concerts, travel. Um, and one of the things that I definitely am looking forward to is hanging out with my friends and traveling with them this year. And so it's something that lab can be, very tough. And the research life it takes no prisoners, but I think that definitely kind of seeking out hobbies and other activities outside of lab. I typically use that to help kind of force me to say, okay, hey, put this down. You can walk away. It's okay.
Yeah, I think that like work-life balance with lab is can be difficult sometimes because you can always be doing something like reading a paper or emailing someone or something like that. So I feel like I'm constantly trying to like deal with that balance as well. So it's nice to hear how you deal with it.
No, thanks.
Okay, so we have a couple of questions on mentorship. So do you have any advice on how we should be approaching mentorship, sorry, and how should we be seeking it out, especially during like post undergrad? And similar along the same lines, what do you think are some great qualities of a scientific mentor?
Oh, wow. That's a really tough question. Um, hmm. I think one of the most important things of mentorship, in my experience, has been finding someone that you feel comfortable speaking with, and that you feel comfortable kind of like understanding that, yeah, the main thing is finding someone you feel comfortable speaking with, but is also kind of doing something, some aspect of their either journey, path, or research is really kind of exciting to you. Because I think that I actually haven't really sat down to actually think about what it was that made my specific mentors really, really awesome. I just know that I've had really, really great experiences. It wasn't always, like sunshine and roses, but I think that even that kind of like I think a great mentor is someone who will be very honest with you, and but also kind of help motivate you to kind of push you. And so I'm not really sure the other aspects of what I couldn't remember all of the aspects of that question.
No, I think you covered them. Yeah, like how do you seek out mentorship, and what do you think are the great qualities of a good mentor? So I think you covered everything.
Sweet.
Uh, and our final question, what is your favorite part of the day as a researcher?
That's a great question. Hmm. I would have to say if I broke it up into beginning, middle, and end, I would have to say the beginning. Because there, that's the point where you're kind of like, okay, I have to actually sit down and think about what I'll have to do today. And it's hard for me to stop working sometimes. So that's like the hard, it's very hard. And I had to figure out kind of when I was when I was motivated, and kind of structure my time to say, okay, this is when you're going to do that, like really tough analysis, or this is when you're going to just sit down and write. But yeah, I would say of the day, the beginning is probably the best, because that's when I'm like looking at email or finding all those papers, and yeah, that I'm like, okay, I'm gonna go definitely read, and I have a huge download to read list. But yeah, I would have to say the beginning of the day.
Awesome.
That's a great question.
Yeah, it's always nice to hear like what other people's favorite part of the day is. Um, I think mine is like the middle of the day. That's when I like get into a groove.
Uh-huh.
um, so everyone's different.
Definitely. Definitely.
Well, with that, we have no more questions. Um, we, as Black and Earl, would like to thank Dr. Tony Larkin for that amazing talk, and also our audience for so many great questions. And happy Black History Month, everyone.
Thank you.
Great talk, Tony. That was amazing.
Great job.
Thank y'all.
I'm really excited to see the PhD, Black PhD student stuff that you're working on. It's like really awesome that you were able to incorporate that into your research.
Yeah, I'm really trying to finish writing that up. It's just that as I and the other people that I've had these discussions and kind of conversations with, everyone's like either trying to defend, put in a grant, or it's like, okay, and we're like, hey, no, let's just keep putting it off. But yeah, I just have been really kind of intrigued with it, because it's one of those things where it's like, I don't know, I ended up coming across this one paper where people the researchers just really dogged like HBCUs, and it just really caught to me. So I was like, okay, Tony, you could write this paper and kind of, help that. So hopefully soon. I was just working on a grant and I have to kind of do some other things, but I'm hoping that as well as some of the other things come out really, really soon. I was hoping to get to talk about it today, but it's okay.
Well,
Oh,
congratulations.
I can't wait.
Yeah.
Sorry, girl.
I said congratulations. Yeah, you've got your hands in lots of different things. So I think the question about work-life balance was relevant. So just make sure you're taking care of yourself. But I'm excited to see the research that comes out because I know you've got some stuff in review. I'm excited to see the diversity work you're doing, and yeah, lots of cool stuff. And if there's ever anything that we can do at Black and Neuro to like provide support or help or partner, we'd be more than happy to.
Oh no, that's awesome. I'm actually just extremely excited that this kind of organization exists now, because that was definitely something right before the pandemic. I like reached out to my mentor, so it's like, there's just this one talk, or not one talk, but this one event at SFN, and that's it. And then it's like, okay, whoa, this whole like it was just amazing to see it, and so I look forward to kind of being involved as well.
Awesome.
So I appreciate you all.
Yeah, thank you.
Thank you. All right. Well, everyone have a good day.
Y'all too.
Yeah, take care. Thanks again. Great talk. And okay. I was gonna tell him the YouTube link if he wanted it, but it's fine. I guess in like the follow-up email, you can send it to him.
I can say I'll send it to him later.
Cool. All right, great job, Ashley.
Thank you. I'll see you later.
Yeah, see ya. Have a good weekend.
Bye. I hope you feel better.
Thank you.